Welcome. This is 12.2. We're talking about chords and arcs. So first thing you need to write down is this right here. Write down what a chord is. A chord is a segment whose endpoints are on a circle. So write that down and then draw that picture right there. This is a chord from P to Q. And again, we just label it like PQ. And it also relates to the arc that we have right here. So a chord is a segment whose endpoints are on arc. And remember, the arc right here is PQ. Remember when we label arc, we have that little arc symbol that looks like that right on top of it. Okay, we got a few kind of more vocabs, so just kind of hang in there as we kind of go through it. Alright, so our first thing, make sure you write all this down. We're going to be talking about theorems and their converse. So remember, converse is if we switch the if-then statement. That's what my converse is. So the first one says, within a circle, congruent chords have congruent arcs. So here are my chords. We're going to say if this chord AB and CD were the same, then the arcs, arc AB and arc CD would also be the same. If we took the converse statement and we said within a circle, congruent arcs have congruent chords. So again, all I'm doing is just switching that thing and saying if the arcs have the same length, then the chords are going to be congruent. Okay. Next one. Next one says within a circle, chords equidistant from the center or centers are congruent. So again, remember, from a line to a point, the quickest way to get there is a 90-degree angle, is to go perpendicular. So again, if these chords are both perpendicular to there, then we're going to say that they are equidistant, that they would be congruent. And then the converse would be the same as well. So if we say a circle, within a circle, if congruent chords are equidistant from the center, so if they're equidistant, then these chords would be congruent that we have right here. So again, we're thinking that as these chords are getting closer and closer, eventually one long chord that we have right here, a long chord from one side to another, we call that a diameter. So as these two chords are moving closer and closer, they're getting closer and closer to being a diameter. Okay, but that's another way that those chords are congruent. The next one says, in a circle, if a diameter is perpendicular to a chord, then it bisects the chords and its arcs. Okay, so again, if I have, here is my diameter, and if I have a chord right here, and it's perpendicular, well then what happens is that these two lengths are going to be congruent, as well as the arcs. The arcs as well would be congruent. Okay, and then if we took the converse of that statement, it would be this. So I know a lot to write down, hang in there. If we wrote down this right here, saying that in a circle, if a diameter bisects a chord that is not a diameter, then it is perpendicular to the chord. So again, if we said here's the diameter and it's bisected, then just like the converse of the last statement, then this would be a 90-degree angle. It'd be a perpendicular angle that we have right there. Okay, so again, a lot to kind of get through. We're not going to write that one last down, but that's the last one, and let's go through some problems. Alright, so make sure that you write this picture down, draw this picture down right here. And so it says, what is the length of RS? We're trying to find the length of that chord. So if I'm looking at this, first thing I notice is this right here, I have this length is 9 and that length is 9. And again, both of those lengths are equidistant and they are both make a 90-degree angle. So by looking at that, using one of our last theorems that we have, we know that the chord PR is going to be congruent to the other chord, which is SR. So again, because these are the same lengths and they create a 90-degree angle right there, this chord right here is going to be congruent to that chord. So all I got to figure out, well, how long is this chord? Well, if this says that is 12.5 and it's congruent, this one is going to be 12.5. So this whole chord right here is going to be 25. And so 25 right here is going to equal what the other chord is, because they are the same length. So again, my other chord is going to be 25. Cool. Pretty easy. Go to the next one. Alright, so on this one that we have right here, make sure you draw the picture. It says, what is the value of R that we have right here? So if I see this, I'm trying to find R. R is going to stand for radius. Because again, I go from the center to the out. That is a radius. So remember, when I create a perpendicular angle with a chord right here, it means it's going to cut this chord in half. So again, this is going to be 7. And I see, hey, I have a 90-degree angle. Looks like I have a right triangle. I have a right triangle right here, 90 degrees, chord, because it's perpendicular, cuts in half, which means this is going to be 7, this is 3, and this is R. So again, anytime I have a right triangle and dealing with sides, most likely we're going to use Pythagorean theorem. So again, I have 3 squared plus 7 squared equals R squared, and again, I know R because it's across from the 90, which is going to give me 9 plus 49 is going to equal R squared, and then I add these together that I have, and that's going to give me 58 that I have. So when I add these together, I'm going to get 58 equals R squared, 58 equals R squared, and I square root both sides, and I get R equals the square root of 58. And if it tells me to round to the nearest tenth, if I take the square root of that to the nearest tenth, this is going to be approximately 7.6 centimeters. Okay, perfect. On to the next one. Alright, and then the last problem that we have right here in the figure, how does the auxiliary AB make the problem simpler? Well, I see that this AB right here creates a triangle that I have right here. I see I have a triangle. And if I see that this chord right here is 11 and 11, well, I know that because it bisected right there, remember anytime it bisects, it's going to create a 90-degree angle. So I have, there's a right triangle. I know a lot about a right triangle. And if again, I look at BE, that's a radius, and AB, that's a radius, well, all radii are going to be the same, so that has to be 15. So when I have this triangle right here, it's a right triangle, and we know that this side is 11, we know this is y, and this is going to be 15. Well, again, we can use Pythagorean theorem in order to be able to solve. So we are going to get y squared plus 11 squared equals 15 squared, y squared plus 121, and then 15 squared, let's just double check, yep, that's going to be 225. We subtract 121 from both sides, and we're going to get y squared equals 104, and we square root right there, and so that's not a perfect square root, so we can round, let's say we round to the nearest tenth like what we did on the other one, and we get y equals 10.2 that we have right there. Okay. Again, a lot of kind of stuff to work through, but we'll go through some more in class. Thanks for coming and watching. See you guys soon.